Hey everybody, I wanted to go through this exam. This exam covers 2.2 and 3.1. So based on the table shown above, which of the amino acid has the highest propensity for being in an alpha helix? So really what we're looking for is the absolute highest number. So 1.42 for alanine, we go up to 1.51 for glutamic acid, keep going. Oh, okay, so of the ones that are listed, we've got methionine, histidine, proline, glycine, so it narrows the scope. Methionine is 1.45, proline is 0.57, glycine is 0.57, and histidine is 1.00. So our correct answer is A for that question. Number 2 is, based on the table shown above, which amino acid is least likely to be found in an alpha helix and a beta sheet? So we're looking for the lowest combination. And if we adjust this just a little bit, glutamine GLN is 1.11 and 1.0, so it's fairly high. Glutamic acid, 1.51 and 0.37. Okay, so that's high for alpha, but low for beta. Tyrosine is 0.69 and 1.47, so that's low for alpha, high for beta. Glycine is 0.57, 0.75. Those are both below 1. Valine is 1.06 and 1.70. So our best answer is D, glycine. Question number 3. The table above is part of the story that allowed us to A, predict primary structure of proteins, B, predict secondary structure of proteins, C, tertiary structure of proteins, and D, predict protein-protein interactions. And the correct answer for number 3 is B. Number 4, the secondary structure of a protein is stabilized by A, covalent bonds, B, backbone hydrogen bond interactions, C, peptide bonds, or R group interactions. B is our correct answer for number 4. Number 5 reads, select the true statement about its secondary structure. Parallel and anti-parallel hydrogen bonds are both stabilizing forces in alpha helices. Incorrect. B, beta sheets are on average 10 amino acids. That 10 is the average length of an alpha helix, not a beta sheet. C, alpha helices and beta sheets are both stabilized by parallel hydrogen bonds. Well, anytime we talk about parallel and anti-parallel bonds or hydrogen bonds, we're talking about beta sheets. And answer option D, parallel beta sheets are generally considered weaker than anti-parallel beta sheets. D is our correct answer. Number 6, glycine is a secondary structure breaker because it is A, too flexible. Rigid is what is the case for proline. So A is our correct answer. 7, peptide bonds are A, resonance stabilized, B, good example of hydrogen bonds, wrong. C, extremely flexible, which enable proteins to have multiple different shapes, or D, relatively weak compared to other bonds in a peptide backbone. A is our correct answer. Number 8, when comparing protein sequences, what is an example of a conservative substitution? A conservative substitution is a residue of one class going to something that is within that same grouping. So answer option A, aspartic acid is a polar residue and alanine is a nonpolar residue. Aspartic acid and lysine. Well, those are both polar residues, but one's polar negative, one's polar positive. So I would say that that is not really a great example of a conservative substitution. They're close, but let's see if there's a better answer. C, isoleucine and leucine. Those are isomers of one another. Those are both nonpolar residues. That you can't get much more conservative than C for number 8. Number 9, you've purified a polypeptide that makes an alpha helix that is 32 angstroms long. How many amino acids make up that alpha helix? Okay, so for this, we've got, let's see, calculator, I got to do this. 32 angstroms divided by 5.4. That means we've got something that's about 5.9 rotations. So roughly 6. So that would be 6 complete rotations times each rotation has about 3.6 amino acids. So 6 times 3.6 is 21.3. So D is our best answer. 21. Number 10, within an alpha helix, hydrogen bonds form between parts of polypeptide backbone. Amino acids. Which amino acids will have a hydrogen bond form? Well, 1 and 2, 1 and 7, 1 and 5, and 1 and 10. The answer is C. The backbones of residue number 1 and residue number 5, or I and I plus 4. That's your best combination. Number 11. Which reagent can be used to disrupt disulfide bonds? Dithiothreotol, also known as DTT, is the correct answer. 12. The oxidation state of iron within a heme ring for a healthy person's blood is, or a healthy patient's blood is B, Fe2+. Christian Anfinsen was instrumental in the A study of the relationship between secondary and tertiary structure of proteins, relationship between tertiary and quaternary structure of proteins, relationship between quaternary and function. No, really folding and unfolding of proteins. He was the one who said the tertiary or the primary structure had everything that was needed for a tertiary structure to be achieved. Heme is commonly known as a prosthetic group. Which statement about the GRO-ELES complex is true? This complex refolds proteins in an ATP-dependent manner. It's going to bind to the protein, bind ATP, hydrolyze ATP, refold that protein, release the ADP, release the refolded protein. Number 16, PO2 is an environmental condition that the protein responds to. The protein oxygen binding protein's affinity for O2, a measure of the oxygen binding protein's affinity for CO2, or D, a measure of an oxygen binding protein's affinity for glucose. PO2 is the partial pressure of oxygen, the pressure of oxygen in the environment. So A is your best answer. If an oxygen binding protein curve shifts to the left, which of the following is true? Okay, so the curve shifts to the left. We've got hemoglobin, the R state is favored. B, the T state of myoglobin is favored. The T state of hemoglobin is favored. Or D, the R state of myoglobin is favored. Hemoglobin and myoglobin are different enough. One way in which they're different is myoglobin does not have a T or an R state. Hemoglobin does. And as that curve shifts to the left, that means the P50 gets lower. That means that the R state is more favored. So A is the correct answer for number 17. Number 18, which statement is true of P50? As P50 increases, a protein's affinity for O2 increases backwards. Myoglobin does not have a P50. That's untrue. Hemoglobin does not have a P50, but myoglobin does. And D, as P50 increases, O2 for affinity for O2 decreases. That is a true statement. So as P50 decreases, affinity for O2 increases. Number 19, hemoglobin's affinity for O2 increases as it binds more and more O2. This phenomenon is known as C, positive cooperativity. Remember, the first O2 to bind is the one that hemoglobin is least likely to bind. It binds that, then all of a sudden it's like, oh, I'll bind the second. Now I'll bind the third. Now I'll bind the fourth. So that's positive cooperativity. Which statement is true about hemoglobin? It is a tetramer stabilized exclusively by ionic bonds. Nope. It's a dimer stabilized by hydrogen bonds. Nope. It's a monomer. Nope. It is a tetramer stabilized by ionic, hydrogen, and hydrophobic interactions. Number 20, B is the correct answer. Number 21, which of the following statements is true? C, when the Bohr effect is enhanced, the oxygen binding curve for hemoglobin shifts to the right. That's 100% true. BPG's highest affinity is for the R state. Nope, it's for the T state. BPG causes an oxygen binding curve to shift to the left. Nope, it's going to shift it to the right. And D, when the Bohr effect is enhanced, the oxygen binding curve for hemoglobin will shift to the left. So C is the correct answer. Number 22. There are 2 histidine residues. I got a couple of questions during the exam about this. So there's a couple of histidines. Those histidines are polar residues. Histidine has a pKa that's smack dab in the middle, about 6.1. So at a pH of 7, it's a little bit less likely to be protonated, but it's possible that it will be protonated. At the end of the day, it's a polar residue. If we mutated that histidine to any other residue, basically, how would it be impacted? If we went to a positive residue like arginine or lysine, well, that's going to be a positively charged residue, but it's got the same classification. That's a polar residue. They're polar positive, but they're polar. Glutamic acid and aspartic acid, those are both polar, but they're negative. But at the end of the day, arginine, lysine, glutamic acid, aspartic acid are all polar residues, which is why alanine is the correct answer, because alanine is a nonpolar residue, which is as far from a polar residue as we can get. 23. Which substance will disrupt hydrogen bonds? Urea. A. 24. How many O2 can bind hemoglobin? A. 4. 25 is C. Myoglobin is the most stabilized when myoglobin doesn't have a T state or an R state. So none of those are good answers.